Okay, we are in, doing experiment 26, series and parallel circuits. This is, I think, step 3. We're doing a series circuit. Now, it doesn't, you see these zigzags, and that's only for, because I had to contort the circuit. Let me show it to you in circuit. Uh, this is the way the circuit looks. Let me open up the, where's the switch? There's the switch. So there's the, it's a little less cluttered that way. That's the circuit. Let's do a new share and show the, let me find the circuit. There it is. So this is, oops, that's not the one I wanted. It's window, that's the one. This is the one we want. Okay, this is the circuit that I've got on here, but I just had to kind of zigzag it. We've got the battery, an ammeter, R1 ammeter, R2 ammeter, R3 ammeter. You need to convince yourself that this is the same as the what I have here on the screen. If you just stretch this out from here to here, if you just stretch it out, you'll see that it's the same thing. Let's go back to the component view. One thing I didn't notice, if you take one of these values, and the last time I did this, I didn't notice this. If you change the values, it changes the color bands. Now it shows 100, brown, black, brown. We change it up to 120, which is the highest it'll go. It's brown, red, brown. So we have brown, red, brown, that's 120. Brown, black, brown, that's 100. And then green, blue, black, that's 56. So those are the values we're working with: 120, 100, and 56 ohms. And if you add those together in series, you get 276 ohms. Now I'm giving you these. I want to see your calculations on your lab report. I upped the voltage up to 20 volts just so that we could get a reasonable reading on the current meter. And so we're gonna 20 volts divided by 276 ohms. We should get about 72 milliamps, 0.072 amps. It's only going to measure one significant digit on this this one. So let's close the switch, and the now you can see on every current meter there's 0.07 amps, 70 milliamps. Now remember, in a series circuit you have one current, but you have multiple voltage drops, and that's what we want to measure. We want to measure the voltage drops. The total voltage dropped across all resistors is, of course, our source EMF, or 20 volts. But now let's measure them individually across the 120 ohm. Now I don't want to cut that. I just want to measure that. I grabbed the wrong thing. There's 8.7 volts across the 120 ohm resistor. Now let's move it to the next resistor, the 100, and it's 7.25 volts. You can see, okay, the resistance is, the voltage is changing depending on where you measure, because it's one current but different voltage drops across each resistor. And there's 4.06 volts. Now you need to do, I'm giving you these answers, but I need to see your calculations that they confirm what we're measuring here. And I think that's it for what we need to do in this section, okay?